All right, so what's the most famous math number in the world? I'd say it's pi. Most people would agree. And my whole life right now is all about proving to everybody that we've gone about figuring out that number the wrong way, and basically it's wrong. Not that it's wrong, like there should be a 7 instead of a 3 or something like that, but it's wrong. The model for that number, a solid line with a little gap at the end when you roll the circle along and you get this infinite series of numbers, but it's still a fixed length. All that is the wrong way to go about it, and it's causing a lot of problems. So this geometric pattern behind me solves all those problems. So this is a base 12 geometric pattern. You can see it's got to do with circles. Basically, it enables the perfect division of the circle. You can see those little black dots there. That's the diameter of the circle, and we divide it into the circumference. So that's the formula for pi, which is an irrational number. And all irrational numbers have this quality of going on forever and no pattern. So that's a base 10 model that we've come up with, and it's a base 10 version of that idea of an irrational number. So irrational numbers are irrational, but there's two qualities to them, and this is what we've somehow looked over. This is the paradox. This is why that guy got drowned back in Pythagorean times, because he was saying, hey, how do you have a number that doesn't land on the x-axis? It's not a whole number. It's always something's not quite right. There's an empty space or a remainder or something. So like square root of 2, it can be proven that that type of number exists. So it's real. But the problem is we've got this definition of a solid line, and actually, in reality, everything is pixelated. At the very bottom, everything is quantifiable. There's space around everything. This is physics, that there's empty space, and that's an actual aspect of the number. So this is why physics has a problem. They go to infinity. These numbers go to infinity, which is not really an end point. It just keeps going. And so we've said, well, it gets so small, that little gap at the end, that it doesn't matter. It just disappears, and it gets close enough to wherever we want to use, whatever distance we want to use, or length, or number we want to use, the infinite point, and then we just say that's the length. But that's a wrong model. And when we are able to access the idea of an irrational number and pi with this model that emerges from this geometry here, we get a picture, a complete unit where there's still space at the end, but it's a pattern. There's a pattern in here. There's a number that emerges from this geometry that has patterns. It's super interesting. It's a complex pattern. I haven't got the pattern. I've got this pattern, the diagram for 360 degrees. That's a pattern, and it leads us somewhere. You see how the edge of that circle, it gets straighter and straighter and flatter. So this geometry takes us into a straight line where the circle and the straight line merge. So that's what I'm working on. If you want to be a part of that journal, follow me, dositomath.com. We're going to do this.